Hello everyone, welcome to my channel. I'm Sarah Rhythm, a student of Sri Venkateshwara College of Engineering, studying under the Department of Information Science and Engineering. Today we'll be learning about variations on mutation analysis. Contents of the presentation are mutation testing, types of mutation testing, procedure of mutation testing, creating mutant programs, changes to make a mutant program, concepts of mutation testing, advantages, disadvantages, conclusion. Mutation testing. Mutation testing, another form of software testing, is a testing in which statements of the source code are changed or mutated to determine whether the test cases can detect errors in the source code or not. It is conducted to ensure the quality of the test cases in terms of its robustness, that it must fail the mutated source code. Mutation testing is not only done to determine the quality of existing tests, but also to design new software tests. In mutation testing, a program is modified in small ways. It emphasizes helping testers develop effective tests and detect bottlenecks in the data test of the program. Types of mutation testing. Value mutations. It is in this testing, the values are modified to find errors in the program. The small value is modified to a larger value or vice versa. Generally, constants are changed in value mutation testing. Decision mutations. In this testing, logical or arithmetic operators are modified to discover errors in the program. Statement mutations. In this testing, a statement is deleted or is replaced by another statement. Procedure of mutation testing. Faults are created into the source code by introducing many versions called mutants. A mutant must have only one fault. The purpose is to cause such mutant versions to fail to show the efficacy of the test cases. Then test cases are applied to the real program and to the mutant program. A test case must be appropriate and is adjusted to find faults in the program. Compare the results obtained from the real program with that of the mutant program. If the real program and mutant programs yield different outputs, the test case destroys the mutant. Therefore, the test case is suitable enough to find the change between the two programs, real and mutant. Creating mutant programs. A mutation is a single syntactical modification made in the program statement. Each such mutant program must be different from the real program by exactly one mutation. For example, in real program, if x is greater than y, print hello readers, else print how are you doing. In mutant program, if x is lesser than y, print hello readers, else print how are you doing. Changes to make in a mutant program. Operand replacement operators. The operand is replaced with another one or with a constant value. For example, if a is greater than b, replace a and b values. If 5 greater than b, replace a with 5. Expression modification operators. An operator or an insertion of new operators is replaced in program statement. Statement modification operators. Programmatic statements are changed so as to create mutant program. For example, delete the else statement in an if else statement. Delete the whole if else statement to determine how a program acts. Some mutation operators are go to label replacements, retain statement replacement, statement deletion, unary operator insertion, logical connector replacement, comparable array name replacement, removing else from an if else statement, adding or replacing operators, statement replacement by modifying data. Concepts of mutation testing. Mutants. It is the mutated or modified version of the source code that contains small changes. When test data is executed through mutant, it yields different results as from the original source code. They are also referred to as mutant programs. Survived mutants. These are the mutants that are still alive after test data is executed through the original and mutated versions of the source code. Survived mutants must be destroyed and are also referred to as live mutants. Killed mutants. These mutants are destroyed after mutation testing is completed. These are obtained from different results from the original and mutated source codes. Equivalent mutants. These mutants are closely related to live mutants, as in they are alive even after test data is ran through them. They are different from others, as in they have same meaning of the original source code irrespective of their possibly different context. Mutation score. Mutation score is the percentage of destroyed mutants with the total number of mutants. mutation score is equal to destroyed mutants divided by total number of mutants into 100. If mutation score is 100%, then cases are considered to be mutation adequate. Studies have shown that mutation technique is an efficient way to measure the adequacy or appropriateness of test cases. An example of mutation testing. Consider a hospital website that allows users to register. It collects various information such as date of birth or age, etc. If a patient's age is greater than 15, a physician is assigned to them as their main doctor. For this, it enables the physician function that finds available doctors. There might be some other functionality. Patients below 10 may get assigned a pediatrician, and so on, but we consider only the age over 15 case. The code may look like read age, if age greater than 15, doctor is equal to physician, NDIF. Note that the code is specific to any language, thus would not run, it is just a pseudocode. We aim to check if the dataset of the 4 values 14, 15, 0 and 5 is enough to discover all problems and redundancies in the code. Now how does mutation testing achieve this? First, we create mutants. Variations of the program are written as a deviation. It comes with a self-seeded issue, example, arithmetic operator replacement, logical connector replacement, statement removal, etc. These replacements are referred to as mutation operators. Advantages of mutation testing. A strong approach to gain high coverage of source program, capability to comprehensively test mutant program, a good level of error detection, detects redundancies and ambiguities in source code, capability to detect all faults in the program, provides a most reliable and stable system. Disadvantages of mutation testing. Extremely expensive as well as time consuming due to large number of mutant programs that have to be generated. An automation tool is a must for mutation testing due to its high complications. Each mutation has the same number of test cases as of the original program, thus a large number of mutant programs have to be tested with actual test suite. It involves source code changes, so cannot be applied to black box testing. Conclusion. The best possible way to execute exhaustive testing is through mutation testing, the most comprehensive way to test any program. This technique checks the effectiveness and accuracy of the program to detect faults or errors in the system. Thank you. Do like, share and subscribe if you like the video.